Welcome to this one. Mr. Sutton here, bringing you the Pre-Cal Honors 2-1 Part 2 homework solutions on solving polynomials by factoring. For this problem, if I try to take out a common factor, that's not going to work out so well. But I do have four terms, so let me try grouping this thing. For the first two terms, I can take out an x to the fourth. That's a whole bunch to take out. That leaves me with x plus 3 inside. For the next two terms, I can take out a negative 16, leaving me with an x, and this is also going to be a plus 3. So now I can take out x plus 3 as a common factor, leaving me with x to the fourth minus 16 as my other factor. Now I'm not done factoring because this x to the fourth minus 16, I'm not down to a quadratic yet, so I need to keep going if I can. Now this is actually the difference of two perfect squares. So I can factor that using my a plus b, a minus b shortcut. Just take the square root of these two things and put them in a plus and minus parentheses. So I've got the x plus 3 coming down, and then we have an x squared plus 4 times x squared minus 4. Again, just square rooting x to the fourth and 16. And now I can set each of these equal to 0 and solve. So for this first factor, x could equal negative 3. For this next one, if x squared plus 4 equals 0, x squared equals negative 4. And then square rooting both sides of that. Since I have a negative, I'm going to have an imaginary answer here. So this is going to be x equals plus or minus 2i. And if x squared minus 4 equals 0, that means x squared equals positive 4 as well. Square rooting that gives us x equals plus or minus 2. So for this problem, a little bit outside the box here, if a, b, and c are the x values that satisfy this equation, we want to know the value of a plus b plus c plus abc. So basically we have to solve this thing, get the three answers, and then plug them into this kind of format. Alright, so first thing to do to solve this, I need to get this zeroed out. So let me subtract this x squared over to the left side to get x cubed minus x squared minus 20x equals 0. And I see these all have a variable, an x, so let me start by factoring that out. That leaves me with x squared minus 1x minus 20 equals 0. I can factor the quadratic here. I need factors of negative 20 that add up to negative 1. 1 and 20 won't work. 2 and 10, nope. 4 and 5, though, might work if we had positive 4 and negative 5. So I can bring down this x, and I have an x plus 4 and an x minus 5. And that means that I have solutions of x equals 0, negative 4, and positive 5. So we need to do 0 plus negative 4 plus 5. That's the a plus b plus c part of it. And to that, we have to add the product of these. We have to add 0 times negative 4 times 5. Now, the good news is 0 just zeroes out this whole second term when you multiply by 0. So really, it's just negative 4 plus 5 that we're dealing with, and that just comes out to 1. So that's choice C. On this one, it doesn't look like I can take out any common factors, but since I have 4 terms, that tells me that we might be able to do this by grouping. So taking a look at my first two terms, I can factor out an x squared. That leaves me with x minus 2. For the next two terms, I can take out a 2. That leaves me with x minus 2. Well, now I can take out that common factor of x minus 2, and that leaves me with x squared plus 2 in another parentheses. Setting these each equal to 0 and solving, we see that x equals 2 for that first factor, and for this next one, we know that x squared equals negative 2. So that means that if I square root both sides here, that x is going to equal plus or minus, there's a negative, so we can take out an I, so plus or minus I radical 2. On this problem, I can't take any common factors out of everything, but since I do have 4 terms, I can try something like common factors, in other words, grouping. So let's see what we can take out of these first two terms. These both have an x squared that could come out along with a 4, so if I take out 4x squared, now I'm left with just x for that first term, and this is going to be plus 5. For these next two terms, I can take out a negative 5. That leaves me with an x and a plus 5 as well. Now I can take out x plus 5, and that leaves me with 4x squared minus 5 in my other parentheses. Setting each of these factors equal to 0 and solving, for this first factor, x has to equal -5. And for this next one, if I set this equal to 0, I could add the 5 and divide by 4, and I would see that x squared equals 5/4. But then I need to go a little further and actually solve this by square rooting. So if I square root both sides, I have a plus or minus, and that's going to be square root of 5 over square root of 4, or just simply plus or minus radical 5 over 2. On this problem, there's no common factors that we can take out. However, there's 4 terms, so we can factor by grouping maybe. I can take an x squared out of those first 2 terms, and that leaves me with x minus 4. For the next 2 terms, it looks like I can take out a 5, leaving me with x and minus 4 there as well. The x minus 4s can come out as a common factor. That leaves me with x squared plus 5 as the other factor. And since I've got this down to quadratic or lower, I can set each of these equal to 0 and solve now. If x minus 4 equals 0, that means x equals 4. If x squared minus 5 equals 0, then subtracting the 5, we can write x squared equals -5. And then if I square root both sides of that, I'm square rooting a negative, so that comes out as an I. So we then end up with plus or minus I radical 5. On this problem, it doesn't look like we can take out any common factors, but we do have quadratic form. We have x to the 4th, x squared, and a constant. So I'm going to try factoring this using x squared instead of x. Now this one's a little tricky because we have an a value out here that's not 1. So that means we're going to have to try the AC method on this one. Been a while since we used that, right? So multiplying the first and the last thing together, 2 times -15 gives me an AC value of -30. And now remember, I'm looking for numbers that multiply to -30 and add up to 7. So let's see, 1 and 30, no. 2 and 15 doesn't work. 3 and 10 show some promise. If I had -3 and +10, that would multiply to -30 and add up to +7. So I'm going to split this up into -3x squared and +10x squared. That 7x squared gets split up there. Now, since I have 4 terms, I will factor this by grouping. I can take an x to the 2nd out of those first 2 terms. That leaves me with 2x squared minus 3. And I can take a 5 out of the next 2 terms, leaving me with 2x squared minus 3. 2x squared minus 3 comes out as its own factor, and now x squared plus 5 is my other factor. Since I've got this broken down to quadratics, I can set each of them equal to 0 and solve. So for this first one, if 2x squared minus 3 equals 0, adding 3 and dividing by 2 gives me x squared equals 3/2. And then if I square root that, I've got plus or minus radical 3 over radical 2. But I can simplify that a little by multiplying by radical 2 over itself. So that ultimately becomes plus or minus radical 6 over 2. Okay, for this other one, it's not quite as crazy. We can write x squared equals -5, just subtract the 5 there. And then square rooting that, we have plus or minus I radical 5 because we're square rooting a negative number.